Okay, so homework 9, 145, same section, 3-3, 21 through 41 odd. No, I'm assuming you already wrote this stuff down.
Yeah, I did.
Yeah, okay, good. 49, 53, 55, 67, 79, 85, and 93. And I think it's like these last 4 are, each one's a doozy. So do not delay. You have, until Tuesday, but still, you don't want to waste time because you may very well have questions with a couple of them. Okay, let's get right into this because I want to get through this so we can get to examples. Please pay attention. Stop looking at your homework. That's you. Yes, you. Stop. Now. All right, guys, here we go. We've done the sum rule, right, where you have the sum of two things, two functions, and you want to take a derivative. We've done a difference. This is the product rule. We have the product of two functions. We're treating this as a function. We want to take its derivative. Turns out that that function is a product of two functions. Can you guess what this is? What do you think it is?
Derivative of f of x times the derivative.
The derivative of f of x times the derivative of g of x. And let's see if that's true. This is what you think, right? Because you have the limit of, where you have the limit of a product is the product of the limits. It makes sense. This has something to do with limits, so it should be this, right? So let's hold off on that for a second. And here's a function, f of x. And it's actually going to be the product of two functions, f of x times g of x. And those two functions are going to be x squared plus 2 times, I think I have 2x minus 3. Okay? X squared plus 2 times 2x minus 3. Everybody buy this? This is one function, but it's also the product of two functions. Yeah?
Yeah.
Now we could rewrite, if we were to assume that this is the derivative, then this would mean that, okay, f prime of x should just be, I take the first one prime, multiply by the second one prime. The first one is x squared plus 2. The next one is 2x minus 3. What's the derivative of this part?
2x plus 2x. Just 2x.
2x plus 0, right? And then what's the derivative of that one? Just 2. Good, you guys are learning something. So this would assume that this is what? 4x. Yeah?
Yeah.
Okay. However, f of x can be written a different way. And if we go first, outer, inner, last, we get, let's see, first would be 2x cubed, outer minus 3x squared, inner would give plus 4x, and then minus 6. And what is the derivative of that?
6x minus
6x what?
Squared minus 6x plus 4.
Is that equal to that?
No.
No, not unless never. I don't think it's ever
So it
equal
isn't
to that.
true.
Actually, they're probably equal at like 2 points. But, so something's wrong here. That's not what this is. And I can tell you right now, that is not the case. And if you want to see why real quick. Okay, so we just found, hold up, I want to have this up on the board. F prime was equal to, it was what, 6x squared. Right, we just did that.
Yeah, 6x.
It was 6x squared minus, or was it plus? I have it written somewhere. It was minus 6x plus 4. Okay, we know that has to be the case. Okay, so, thinking about this as a function, we want this prime. It's the same thing, we'll just call f equal to f times g. Everybody with me on that? Like from here on out, I'll just go ahead and do it. Let's call big capital F the product of two functions, f of x times g of x. And we want to know what is f prime of x. Well, that's the limit as h goes to 0 of f of x plus h minus f of x all over h, which is the same thing as, let's do it right here. You tell me what to write. What would it be?
Limit as h goes to 0 with f of, well, it's little f of
little f of
x plus h times g of x plus h.
G of x plus h.
Minus f of x times g of x.
There we go. Okay, now here's the thing. And if this were simply equal to the product of the two, right, as like we assume f prime times g prime, then this would have to be equal to the limit f of x plus h minus f of x all over h times the limit g of x plus h minus g of x all over h. And you could fiddle with this all day long, and you will not be able to turn this into that, or turn that into this, because it turns out it's not true, as we just saw with this example, okay? Everybody with me on that? Okay, so that's why it doesn't work. But here's the, okay, so then what is it? And this is where, do I want to do, I think I'm going to go ahead and throw it up on the board without showing you how to get it. Because if you just tried to manipulate this thing, you would have no idea where to go. To turn it into something. Like, really, what do you do with that? I don't know. Like, can we make this easier on ourselves? Get it in terms of f and get it in terms of g? I don't know. But knowing what it is ahead of time will help us to see if we're going in the right direction. Now, I don't know who originally figured this out. I'm sure they were pretty bright, but it turns out to be f prime times g plus f times g prime. That's what it works out to be. And like after today, whenever I write one of these rules up, I'm just going to do it real quick like this. F of g prime equals f prime g plus f g prime. I'm not going to do the of x stuff, but this is what the product rule is right here. Okay? Now, let's prove that. Okay, so first off, I have an idea of where I'm trying to go, but again, I'm not quite sure how to get there. So, there's something to notice. We have two different flavors of f and g. One of these f's has an h in it, the other one does not. One of these g's has an h in it, the other one does not. This is kind of, I'm thinking here, and just seeing that it says product rule, I'm thinking this almost looks like, so we kind of have four different things. Let's just call one x, one y, the other one u, and the other one v. And if I'm thinking about a product, this makes me think of is it's almost like, this almost looks like you have a product of two sums. One has an x here, or maybe it doesn't. No, one would have an x and one would have a y. One would have a u and one would have a v, something like that. Right, with maybe a plus and a minus. The only problem is it's the inside-outside parts that aren't here, right? You see what I'm saying? Like if I did first, outer, inner, last, my first would give me my xy, which is what I want. The last would give me my minus uv, but it looks like I'm missing a bunch of stuff right here. And the things that I would be missing would be the mixed terms, right? My x and my v, and my y and my u. And so when I'm just looking at it, I don't know if like this is how the first person who figured this out, this was their reasoning or not. But knowing that I'm heading in this direction, I'm gonna think, well, what? Let's just see what happens if I have one of these mixed terms in there. And what I'm gonna do, I'm just gonna say, okay, let's do it this way. As h goes to 0, I'm going to give myself some room and say, okay, I have this thing, this f of x plus h. I have my g of x plus h. And on one hand, I kind of see where I'm trying to go here. Like, part of this needs to have an f prime in it, so I'm thinking, well, if I subtract off an f of x, that almost looks, but now, what happens if I add this g, if I had a g of x plus h right here? Then I would, just forgetting about the rest of this, that would be nice. Because then I'd be able to factor that out, and I would have something that looks like the derivative there. But I can't just willy-nilly subtract something off. What trick could I use?
Add it.
I could add it back in. And so I could say, okay, let's add the same thing back in. And this is like, again, if you didn't know this, you'd never guess to do this, right? Unless you've done a bunch of things like this before and you've seen this trick. But the idea here is like, well, Again, we're also kind of missing, you can see how this is a mixed term with an x and the different flavors, right? One's an h, one's not, you know. Now, I could have done the same thing with an f plus h and a g, but whatever. Just, this is the idea here. Does everybody believe that this is true? I've not changed any. This is, by definition, this thing right here. That's the derivative of the thing that we're trying to find. And all I've done is I've added and subtracted, so I haven't changed it at all. But now, let's see what happens here. In fact, I'm going to go ahead and do this. I could split this up like this. Yeah?
Yeah.
Everybody buy that, right? Same denominator, so I could split it into a sum. And now, look at this. I have a g of x plus h and a g of x plus h. I could factor that out.
Yeah.
I have an f of x, I have an f of x, I could factor that out. And the only reason I wrote this up here ahead of time was because, well, really, we're not trying to do this from scratch. We're trying to show that this is true. And doing this makes me think, I think I'm on the right direction here. Because now I'm going to have a g out by itself, which is what we have there, a g all by itself. We're going to have an f all by itself, which is what I'm looking for. And so, yeah, I feel like we're heading in the right direction here. Limit as h goes to 0 up. Now I'm going to factor out it out like this. Everybody buy that? Is that the same thing? I haven't done my parentheses, which I guess I could do. I could do parentheses like this. I mean, I could have kept that in the numerator, right?
Yeah.
Like I could have written that all like this, only with one g in parentheses here. I'm just kind of cutting to the chase here, right? And this is plus, I'm going to factor out my f of x this way. Give myself a little bit of room and say f of x this way. And now what's left is my g of x plus h minus g of x all over h. Everybody believe that this is the exact same thing as our original. Okay. The limit of a sum is the sum of the limits. So I could say this is the same thing here. I could see why I gave myself some room.
Yeah.
Right? Okay, everybody buy that.
Yeah.
Okay. This is a product. Here's one thing. Here's another thing. Limit of a product is a product of the limits. Right? And so I could say this is the same thing as the limit as h goes to 0 of the first stuff times the limit of this. The limit as h goes to 0 of g of x plus h. Now add that to, a big plus here. Add that to, now the limit of a product, something times something else is the product of the limits. Provided that the limits exist. I haven't been saying that. G x plus h minus g of x. Okay, I'm going to stop. Is everything good here?
Yeah.
Right? This is exactly the same thing as that. I've added and subtracted a term, but that hasn't changed anything. Why would I do this? Well, and why didn't we just leave it like that? Or maybe leave it here or something like that? Well, if you have an f and you have a g, this is actually quite easy to derive. You could take the derivative of f and multiply it by your original g. You could leave f alone and multiply it by the derivative of g. This is something you can do. This tells you how to do this. This would be a huge pain. Could you imagine plugging this into here and what you'd have to do? This, we're breaking it down into its component parts, and we're getting to something. And so, the same way as before, when I said I'm not going to write one of the caveats to each one of these rules, is that that has to exist, and that has to exist, right? It's like, yes, this is equal to that if that derivative exists, and that derivative exists. And so, since this derivative exists, that's the assumption, then this is the same thing as f prime of x. What is this? What's the limit of f of x as h goes to 0?
F of x.
It's just f of x. Because as far as h is concerned, this thing is a constant. right?
Yeah.
F of x itself does not change when you change h because h doesn't show up in it. Another way you could think about this was the very first time we did a derivative. It was like x squared. Or actually, yeah, the function was x squared, and I said, let's find the derivative at 2. And for x, I plugged in a 2. You could think about this way. It's like, I want to know what this is at, say, 5. And so I plug in a 5. And everywhere you see an x, you just replace it with a 5. And now you have f of 5, which is just some number. And if f happened to be x squared, it would be 25. You would have a 25 right here. H does not care about 25, right? This is just, as far as H is concerned, this is a constant. And so this just works out to be f of x times, what's that?
The derivative of g.
That's g prime of x, because we're assuming it exists. Now what about this?
Well,
if x is 0, then it's just...
If h is 0.
Yeah, because the limit's going to 0.
The limit's going to 0, and so it should just be... But what is that? Isn't that like the definition of something? Almost. And here's my question, is this it? Can we do that? Because if you think about it, what is it? We had it something like this. The limit as x goes to, say, a of g of x does indeed equal g of a, which is kind of what's happening here, right? Yeah. You could say as h goes to 0, that's kind of the same thing as saying this is the limit as y goes to x of g of y equals g of x, right? That's kind of what we're doing. Y here would be x plus h. X plus h is going to x. It's the same, right? It's the same thing.
Yeah.
And so this isn't always valid. You can't always do this. What must be true about g for this to hold? G has to be
Continuous.
It has to be continuous. Is g continuous?
Yes.
How do you know?
Because we took the derivative.
Yeah.
Because remember, if it's differentiable, then it must be continuous. And so this means it's differentiable at x. And we've proved before that if a function is differentiable at x, then it must be continuous at x. And therefore, this is true. You can do this. It's a nitpicky little thing, but you can't just assume that you could just plug in a 0 and everybody's happy. But because we assume that this exists, that implies that g is continuous, and therefore that limit does indeed do that. And so we have f times g prime equals f prime g plus f g prime. Everybody buy that? Yeah. And we've proved it. Okay, we're good to go. Now let's come back to this and use this to calculate it. So we have f of x times g of x prime is f prime g plus f g prime. Or as I say, and I will be saying a lot, take the derivative of the first thing, leave the second thing alone. Add that to, leave the first thing alone, take the derivative of the second thing. And so, here, let's just plug in our f's and our g's, right? F was this guy here. X squared.
How do we know
plus.
which one is x and which one is f and which one is g?
In this case, it doesn't matter, does it?
Yeah.
Flip them around, and because it's addition, it won't matter. If there was a subtraction sign, then you'd have to be careful. But this does not matter, because it doesn't matter which one you multiply, front or back, right? Or because the property of multiplication, it's the same whether you go a times b or b times a. And so it's nice that the product rule, since products don't matter which way, then the product rule doesn't matter which way. In a minute, we're going to see something else. And so I'm just going to plug this in, 2x minus 3, x squared plus 2, 2x minus 3. Okay, so what's the derivative of this?
2x.
Okay, 2x. That is, leave the first thing alone, take the derivative of the second thing. That's just a 2. And so now let's distribute this guy through.
4x squared minus
4x squared minus 6x
plus 2x
plus
squared plus 4.
2x squared plus 4, which is 4, oh, nope. How many x squared?
6x
6x squareds.
minus 6x.
Is that what we got when we did it the other way?
Yeah.
Nice. Okay, so that demystifies it. That's why that is that way. Okay, now, just having said this, I personally think it's easier if you're given something like this, like just two polynomials, it's much easier to just multiply them out and take the derivative.
Oh.
However, this is good exercise to do it this way. In fact, I think you have one, maybe two homework problems that have you do it both ways, okay? And then a bunch of them that have you do it this way. And that's just to get used to using the product rule, okay? Now then, there are ones that aren't easy to multiply out. Like, for instance, if you had, say, the square root of x times sine x. That, you can't multiply that out, and you'd have to use the product rule. I mean, yes, the product rule for that, because that's a product of two functions. We'll get to the trig function soon, but anyway. So, any questions on that?
I don't think so.
Okay, so that's the product rule. Let's do an example. This is number 24. We don't need him anymore. We'll leave the product rule up there. Also write it short notation. F times g prime is f prime g plus f g prime. That's how I think about it. Number 24 gives you a y of u. Y as a function of u is the product of two things. And you, this one, I don't know if I would want to multiply this guy out, because this is u to the negative 2 plus u to the negative 3. U to the 5th minus 2u squared. Okay. We want to take the derivative. Y prime of u is, and this is how I would do this. This is how I just think, okay, product rule. Take the derivative of the first thing, leave the second thing alone. That's what I'm going to work on first. Okay. Take the derivative of the first thing. What's the derivative of the first thing?
Negative 2 u
to the negative third.
U to the negative 3
plus negative 3 u
to the negative 4.
to the negative 4. Leave the first thing alone. Add that to, leave the first thing alone. Multiply that by the derivative of the second thing. So what's the derivative of the second thing?
5u to the 4th minus 4u. Yeah, 4u.
Just plain old 4u. And as far as I'm concerned, that's fine. Like, if I gave you this problem on a quiz, you're done.
Oh, yeah.
Okay? I mean, you could, sure, rewrite it. I mean, now in the back, now here's the thing. The answer to one of these, in the back of the book, they may have multiplied it out. In which case, multiply it out and check your answer, right? What a pain. I mean, you got to FOIL this out twice. There's probably stuff that's going to cancel. Maybe not. I don't know. Who cares? This is a perfectly good answer as far as I'm concerned. Unless I tell you to multiply it out and cancel. Or if you had this over something, then you might want to see if something cancels. But just as a rule of thumb, if this is where you are, you're good. Just leave it. That's perfectly fine. Plug that into a computer and it'll grab it for you, you know. So, everybody with me on that?
Yeah.
Okay, I want to move on pretty quickly because I do want to get to examples. A bunch of examples at the end. Okay, so we did a product rule. Can you guess what rule is coming next?
Division or quotient.
Quotient. Quotient rule. So this is when you have the quotient of two functions. Now, notice, this is good that you said this earlier. F times g is the same thing as g times f. But now f over g is not the same thing as g over f. Unless it happens to be the case that f squared is equal to g squared. But so, this one's not going to be symmetric. It will depend. And this is a real pain. This is such a pain. So it's very much like the product rule on the top. F prime G minus F G prime all over G, not just G, whatever G is, squared. Not too bad, right? And so I would write it like this. F over G prime is F prime G minus F G prime over G squared. That's how I keep that in my head right there. So notice the way that I've written it, the book is a little bit different. They mix up the G's and the G's and the F's. And I prefer to do it this way because the way I have the product rule in my head is it's FG each time. FG, FG. And then it's this one, and you add them. With F over G, you'll notice it's the same format. It's FG, FG, and it's even the same derivatives. It's the F prime G, FG prime. The only difference is there's a minus. And yes, G is squared in the denominator, but... Okay, so let's prove that. Are we ready to prove this?
Yes.
You think so? You think you are? So, we're supposing that this is some function, f of x. F of x, big F of x, is actually can be realized as the quotient of two functions. Some function divided by another function. So, its derivative, just by definition here, is going to be at big F of x plus h minus big F of x all over h. Now let's plug in values. And we're going to get something here. So, big F of x plus h is what?
Little f of x plus h times g of x plus h.
Times g of x plus h?
Or minus.
How about divided by?
Wait. Oh yeah. Yes.
Right? So big F of x plus h would be little f of x plus h over
G of
x plus h minus what?
F of x over g of x.
Okay. Now, a lot of places we could go from here. A lot of places. But one thing I notice is I have denominators, and I hate denominators. So what am I going to do to get rid of those? I'm going to kill them, okay? And the way I'm going to kill them is say, okay, I'm going to multiply the thing that I need to kill each denominator is going to be g of x, g of x plus h, right there. Do that at the bottom. And does everybody agree that that's going to do it? That should get rid of those denominators right there. And let's see what's left. I have the limit as h goes to 0 up. Okay, so the g's come over, that one kills that one. And so I have f of x plus h times g of x. This one jumps over and kills that one. The g's are gone. And I have g of x plus h times f of x. So I have minus, you see how I'm giving myself some room here? Because I'm anticipating what's about to happen. Now, in the bottom, I have an h and a g and another g, like that. Right? Denominator comes in, it's just h times that stuff. Numerator, why did I write it so big? Well, because now I'm in the exact same, almost the exact same place that I was before. Almost. But now it's like, well, I'm just going to kind of do this same thing. I noticed that this part would look like a derivative if we had a minus f of x. And I'd be able to factor out a g if I put that with a g. So I'm just going to try that. Minus f of x times my g of x. Can't just add them in by willy-nilly. I got to get them out of there. So plus f of x, g of x. Everybody buy that? Mm-hmm. Okay. Now this is nice because I'm setting myself up to pull out a g. That'll be good. Here, though, it's not, the derivative is not g of x minus g of x. It's the other way around.
Oh, yeah.
We'll get there. So, here we go.
Oh, that's what you like, because you just switched.
Yeah. And so, another thing that's going to be really annoying, if I don't get rid of it right now, because I don't want to take up too much room. I'm gonna get these guys out of the way too. The book does this differently, but I could just rewrite this as 1 over g of x times g of x plus h, like that.
Yeah.
Right, that's the same thing as just multiplying by this. If they're in the denominator, right, that's all it's gonna, 1 gets multiplied on the top, that gets multiplied there, it's the same thing.
This.
Okay,
And now you can see it.
almost there. Let's do this trick again. Yeah?
Yeah.
Nice. Okay, just saving myself some room, really. Now, the g comes out, so I'm going to do that. The limit as h goes to 0 of f of x plus h minus f of x all over h. Pulling that g out, I could write that way. I could keep them in the numerator if I wanted and do parentheses, or I could just do that. That looks good. Same thing here. F of x can come out. But then I'm in this weird situation. What can I do to flip this around? Because I want it flipped around because I want the derivative. I don't want the negative of this.
Just make it minus.
So yeah, I'm not just gonna pull out an f of x. I'm gonna pull out a negative f of x. And what that does is flips those guys around. Or really, it makes it negative g minus a positive g. That's the x plus h right there, right? That's what I've done. I pulled out that negative f.
Yeah.
Right? And so now I'm going to flip it around and go, okay, so that's g of x plus h minus g of x all over h. Everybody buy that?
Yeah.
Let's just double check that. I want to make sure I haven't messed anything up. Throw in the negative. Negative f comes in, multiplies that guy, and gives me my negative f, that guy.
Yeah.
Negative comes in, hits the negative, becomes positive, so now we have plus fg. Plus fg. Okay, we're good to go. We're good to go. Now take your limits. Same thing as before. Limit, I'll go ahead and do it. Limit of the f of x plus h minus f of x over h times limit g minus, right? The limit, that's the limit of a difference, which is the difference of the limits, and so that's the limit of all that stuff. But that's a product, so it's the limit times the limit. And all of that is multiplied by this guy.
Oh, right.
Well, actually, and so what I should have done then is you notice I'm being a little sloppy here. Okay, so there's the 1 over the g times the g.
Oh.
Right?
Yes.
And so that's a limit of that. So that is actually the limit of a product. It's the limit, this is the, ooh, look what I did there. Man, I'm messing this up. That's what I get for being sloppy. It's all of that stuff times this. Yeah?
Yeah.
It's all of this times this, and it's the limit of that. So here's my product. It's a limit of the product of two things. So that's times the limit as h goes to 0 of 1 over g of x plus h. Yeah?
Yeah.
Yes. So that is all of this right here, right?
Yeah.
All of that right there.
All.
So that's times the limit as h goes to 0 of 1 over g of x plus h. Okay, now, finally. That gives us, what's that?
That's just, yeah.
That's the derivative, f prime of x times
Just g of x.
just g of x, because it's a constant as far as that's concerned. Here's my brackets, don't want to forget my brackets. Minus, that's just f of x, because x does not care about h, so that's just f of x times,
G prime. Yeah.
so there's all that stuff. What's the limit of this?
1 over g squared.
Yeah, because if you, so here's the thing, right? Like we talked about last time, this limit exists. Therefore, g is continuous at x. So I can just plug in a 0 in for h. And so that gives me 1 over g of x times g of x, which is just whatever g of x squared is. And there's another caveat to this, like as always. So we're almost done, right? I'm going to come way back up to the top and say, well, let's just put all this together. Let's put all this together. Ready? Let's say that right there is equal to all that stuff in the numerator and that stuff in the denominator. So here's the stuff in the numerator, f prime of x, g of x, minus f of x, g prime of x. And now into the numerator goes that guy, which is whatever g of x is, squared. And the obvious caveat, wherever g of x is not equal to 0. If g of x happens to equal 0, well then this is obviously is not going to work. Neither would that have worked, right? You're saying like, what's the derivative of infinity? Shut up, you know, that's not a thing. So we could pretty much, that's why I don't start with all of the preamble, like, provided that f is differentiable at x, and g is differentiable at x, and g is non-zero at x, like, obviously, right? If any of that fails, then this doesn't work. Everybody buy that? Okay, all right, proved. Boom. I want to start this year, I think. I want to do boxes and then immediately erased. And just like, why did you bother with the box? Like, just got to. It's a compulsion. All right, so let's leave that up there, and we'll do an example. Here's number 28. I think it's f of t. Is it f of t is equal to 2t over 4 plus t squared. Okay. Okay. It's a quotient. Okay. So I'm thinking, okay, and yes, it's take derivative of. Take the derivative of this. Find the derivative of f. So, okay. So I'm going to think about it. Just like the product rule, but with a minus in between. So this says, take the derivative of the top stuff, leave the bottom stuff alone.
Yeah.
Subtract off, leave the top stuff alone, take the derivative of the bottom. Take the derivative of the bottom stuff. Divide that by whatever the bottom stuff is, squared. Now all we got to do is just take two derivatives. Okay. So what's the derivative of 2t with respect to t?
2.
2 times 4 plus t squared minus 2t times, what's the derivative of that?
2t.
Another 2t, right? Because the 4 goes away. The derivative of that, the 2 drops down, comes down 1. Yep, okay, good. And that's all over this. So now, technically, we are done, but maybe something will cancel out. This is what I was saying.
Oh, wait, no. Yeah.
It won't, but here's the thing, you won't know. And so I suggest that when you do these, just go ahead and multiply that guy out. So that's 8 plus 2t squared minus 4t squared. Is that right?
Yeah.
Minus 4t squared. Yes. All over 4 plus t squared, quantity squared, which gives us 8 minus 4t squared. Nope.
16.
Nope. Try again.
Are you multiplying out the bottom? Oh, I see. Oh.
This one happens to not cancel anybody. But it's a little bit nicer to write than that, so whatever, right? So I'm gonna request that when you do these and there's a denominator, go ahead and multiply the top out and try to reduce as much as possible. Sometimes it will cancel out, and that's nice. In this case, it didn't, so whatever. But there's your answer.
Wait, why can't we just get rid of one of the 4 plus t squared?
Where?
Where's a 4 plus t squared? So are you saying that because of this,
Wait, why is there a minus?
Wait.
Look, it's 4 plus t squared right there. 2
Oh,
times.
he factored out the 2. Is what he did.
what are you talking, where's, so
2 times 4 plus t squared minus.
2 times 4 minus t squared.
He just factored out the 2.
I factored out a 2.
Yeah,
That's a minus.
up above.
That's a minus.
One
He
below.
was thinking
Where?
the 2 times 4 plus t
2
squared.
times 4 plus t squared.
But
That's 8 plus 2t squared.
I know, why can't we cancel that?
Because
4
it is-
plus t.
Because there's not one over here.
Oh, okay.
Watch. 4 plus 1 over 4. Why can't you cancel the 4? Why can't you cancel the 4?
because there's no 4 in it. 1.
You have to be able to factor it out in order to cancel it.
Yeah.
Right? Now, or like 2 plus 2 over 2. Now you can pull a 2 out, right? Because there's a 2 in each one. And so 2, 1 plus 1, 2. Now it cancels. But you can't just cancel something here,
Yeah.
right? So, just because this is the case, 2 times x minus some other stuff, maybe 7, over,
X squared.
yeah, like x squared. You can't just say, oh, let's cancel an x. That doesn't work.
Yeah.
Right? So that's what we're going on here. You can only cancel once it's once. If there were a 2 down here, you'd be able to cancel that. Or if there was a minus here, you'd be able to cancel that. But that guy out there by himself does not cancel down here. You did that, I think, on your summer project or something.
Yeah, I might always.
Yeah, oh yeah. And I think I berated you for it. I think I might have even ripped the paper writing comments on it. No, so yeah, be careful with that. Don't just see, oh, I have something in the numerator and the denominator, it cancels. No. I mean, if that were the case, f prime g minus f g prime over g squared, you could just say, oh, cancel. That's the same thing as f prime minus f g prime over g. But that's not true. That's not the case.
Yeah.
Right? So, okay. I want you guys to pay attention to the way I've been saying this stuff. We'll do it again. There's number 42. And every time we do these, I'm gonna say this. I'm gonna describe it because the way that I say these rules, if that's how it's in your head, it's gonna make your life easier. I'll show you what I mean. So we're gonna find f prime. We're gonna take the derivative of this. And this is what I mean. Take the derivative of this. It's a quotient. So I'm gonna go ahead and set this up. I know what that's gonna look like. Cx plus d squared, right? Now, it's take the derivative of the top stuff, leave the bottom stuff alone. Subtract off, leave the top stuff alone, take the derivative of the bottom stuff. You'll notice if you have it in your head like that, right? Because that's what I did, right? I said you have an f and a g. And I said, okay, the bottom stuff gets squared. Take the derivative of the top stuff, leave the bottom stuff alone. Subtract off, leave the top stuff alone, take the derivative of the bottom stuff. That way, you're not, I mean, if you need to like write this out first and do like we did before where you write in your, okay, ax plus b prime, cx plus d, minus ax plus b, leave it alone, cx plus d prime, do that for the time being. But the way I do it, you'll notice if you say it slow enough, you could just write it as you do it, right? Like I just did. Now, since there's a denominator, I'm going to go ahead and multiply out because maybe something will cancel. ACX plus AD, that's going to be minus all of this stuff. So that's minus an ACX minus BC. Everybody got that? Alright, cx plus d quantity squared. These guys cancel, and we get AD minus BC. CX plus D squared. There you go. Anybody want to see that again? I mean, like, I just blew through this. I just wrote it down. I didn't write any of this stuff down. I didn't have a plan. Did everybody follow that? Okay? These are nice. They're linear, so they're easy to take the derivative of.
Yeah.
It's, yeah, super easy. So, okay. So that's another example. Here's another example. Number 56. Oh, okay, all right. Now here we go. This is where it gets. This is where it's going to start. You're going to have to use your brain. So up until about this point, maybe 50. I'm not sure. But up until about this point, it's just take derivative of stuff. Take the derivative of this. Take the derivative of this. Now that you've taken a bunch of derivatives, let's apply this. So watch this. Find the tangent line. And normal line. Ooh, what? we will talk about what that is. To the curve.
Oh, is normal line like?
What do you think it is?
The line that fits it best overall.
No.
The average.
Nope. You'll see. I'll show you in just a second. To the curve at this point, and it gives you 4.04. It's going to be a lot easier if we write 0.04 as 2/5.
Yeah.
Okay, trust me on that. It will be much easier if you do it this way. But, you know, whatever. Have fun. So, okay, what's the curve? Well, here's the curve. It gives you this. Y equals root x over x plus 1. Okay. Yep, that's it. So, what are we looking for? So here's the curve. If you were to graph it, it looks something like this. You plug in a 4, you get out a 2/5. Does that look right? Plug in a 4, that guy's a 2, square root of 4 is 2. Plug in a 4, you get a 5, that's 2/5. Okay, nice. So the the tangent line is this line right here, right? It's tangent to it. Okay. The normal line is perpendicular to that. And so the normal line is the perpendicular line right there.
Oh. I never would have guessed that.
So normal is a math way, I think physics way as well, of saying perpendicular to. So this line is tangent to the curve at that point. This line is normal to that curve at that point. Clearly it's not tangent to it over here, right? Yeah. So you just say the tangent line, it's not the tangent line to the curve. You have to say tangent line where? Unless it happens to be a line, in which case, blah, 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 blah. Okay, so y prime equals, it's a quotient, so I need a denominator squared. Now, it's f prime g minus g f g prime, right? So, take the derivative of the top stuff. What's the derivative of that?
X to the 1/2.
What is the derivative of
1/2 to the x to the negative 1/2. 1/2 times x.
1/2 times x to the negative 1/2. So take the derivative of the top stuff, leave the bottom stuff alone. Subtract off, leave the top stuff alone, take the derivative of the bottom stuff, which is 1.
So,
nice. Okay. Now, yikes! Okay, here's the thing though. Okay. It's actually not that bad. And I'm only gonna clean this up slightly. I'm just gonna rewrite this as 1/2 root x, right?
Yeah.
X to the negative 1/2 is the same thing as 1/x to the 1/2, which is 1/root x. So 1/2 of that would just put a 2 in the denominator, right? Yeah. The derivative of root x is really nice to remember. Just remember it does that. It's going to show up a lot, so you might as well remember that. Okay, so that's that times x plus 1 minus root x all over x plus 1 squared. That is y prime at any x. So the derivative of that curve is that right there. Now, I want to find the tangent line. The tangent line, what is the equation of any line?
Y equals mx.
Mx plus b. Your life will be so much easier if you start every single one of these problems by writing this down. What is m there?
Slope.
Yep, how do we find the slope?
Rise over run.
Okay. It's the
It's
slope
the
of what?
derivative.
It's the slope of, I mean, yes, it's the slope of this line, but that's determined by what?
The curve.
The curve.
Yeah.
And so how do you find the,
The
slope? The derivative! Okay, there's your derivative. What do I need to do to find the
Plug
slope?
in a 4.
Plug in.
Plug in a 4. Okay? That's what the derivative is. The slope of this curve at 4 is whatever you get when you plug in a 4. And you can imagine that you did the difference thing, right? And instead of plugging in an x, you plugged in a 4, right? You plug in a 4 there and go 4 plus h plus 1 minus 4 root 4 blah 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 blah, and you would end up with this, only everywhere that there's an x there would be a 4. So m in this case is equal to f prime of 4.
Yeah.
Right? Oh, sorry, f prime. Y prime. Sorry about that. Let's call this f so that we're not... Yeah, because now we're dealing with different y's and yeah. So let's call this f of x. So then f prime of x would be that, and f prime of x would be that. Okay, so now, yes, the slope of this line needs to be the same as the slope of the curve at that point. You find that by plugging that number in. And so we have 1 over 2 times root 4, 4 plus 1, minus root 4, all over 4 plus 1 quantity squared.
So 1/4 times 5.
5 quarters
Yeah. Minus 2.
minus 2 over 5
5.
squared. Yep. And you can work that out and you end up with -3/100ths.
What? Oh yeah, I guess.
And if you-
Yeah.
Yeah, because this is,
Yeah.
so there's another way you could, right, multiply the top and the bottom by 4. That's one way you could do it. Right, then you have 5 minus 8, which is minus 3. The
Over.
25
Yeah.
times 4 is 100, right? So that's in its most reduced form. So we know that m in this case is -3/100.
If you flip it and make it negative, wouldn't
Yeah.
you do the
So then
flip?
it's-
Yeah, and so now here you go. So the slope of the normal line is -1 over the slope of that one, which is just what?
100/3.
100 thirds, right? So if it happens to be a fraction, flip the fraction, make it negative. Or if it's like the square root of 2, it'd be -1 over the square root of 2 or something like that, right? Everybody buy that? Can I hear a yes from both of you?
Yes.
Yes, okay. So that's how you'd get that. So now, hold up. We know that. We got all that. Now, do I have everything I need? I have my M. How do I get my B?
We're gonna need to plug in
Plug in what?
A 4.
4 and 2.5.
Okay, so first off, let's plug that guy in. We have minus, so we know that the slope of this green line right here has to be that. And now what are you telling me I need to do?
Plug in
Plug
x
in
and y and solve for b.
Yeah.
Okay, so what do I plug in for Y?
2/5.
2/5. My output. So in other words, this line, this green line right here, when I plug in a 4, it had better pop out a 2/5. So when I plug in a 4 for x, it had better pop out a 2/5 for y. You see why back in Algebra 2 I said do it this way every single time?
Yeah.
Right? Like you don't want to have to be like, whoa, hold up, I have this formula for this. And
Oh
that.
yeah, like negative
It's just
something over. I don't even remember.
And so,
Another
yeah,
way.
right, there's another way to do it. And
Negative
so,
for M.
2/5 plus 3 times 4, how about is 12 100ths equals B, which
is like
Multiply
4
the
25ths. No, 3
20,
25ths.
so it's 40, 100. 52 hundredths?
Yeah.
Probably. I got 13
I think it's
25ths.
Oh yeah, because that's,
Is that 52 or 25?
I don't know.
Yeah, that would be.
Yeah, it's something like.
Whoa, 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 whoa.
13 25ths is 52 hundredths.
Well, 12 hundredths is
Because
3.
multiply-
Oh, here you go. This is how I did it.
Yeah, that's.
Just do it this way. 4 and 100 cancel. Yeah?
Yeah, so it's negative 3 over.
Negative
25.
3
Oh.
over 25.
Yeah.
Multiply the top and the bottom by 5.
Yeah.
And you get,
Negative.
this is plus b, so
10.
10 25ths.
And then you add.
Add on the 3 25ths.
Yes.
Right? Bring that over to that side and you get that. And so that you get then your b is 13 25ths. So finally, your answer for the tangent line would then be y equals minus 3 100ths x plus 13 25ths. And if you're like me, you had no idea what that thing looked like, and you had to go to Desmos to graph this. But now that you've graphed it, then you can see, yep, it should be a negative slope, and the y-intercept of that guy has got to be up there somewhere. Is he up there somewhere? Yeah,
We
okay.
also need the y-intercept of the,
Looks
of the
good.
normal line.
Yes, we do. So,
Same thing, but
Same
different
thing.
slope.
right, and so, normal line now. Normal line has the form y equals mx plus b. We know that m is equal to 100 thirds, and so let's plug that in. Y equals 100 thirds x plus b. Now what do we do?
2/5 equals.
Right, because when I plug in a 4, it also has to give me a 2.5. So I'm going to do it this way. When I plug in a 4 into this function, out pops a 2.5. Input, output. And so now I do some magic and I get
Something.
negative 1,994 over 15. It's actually not that bad. It just happens. It's like 2,000 over 15. Or it's like 6 over 15 minus 2,000 over 15. And so, yeah. So, okay. So then the normal line is y equals 100 thirds x minus 1994 over 15. Again, let's assess this. It's a positive slope. Should it have a positive slope?
Yeah.
Yep. The y-intercept is negative. Should it be negative?
That makes sense.
And what you could do is then go to Desmos, graph him, graph our green tangent line that we didn't do, or that is not up here anymore, and then graph your normal line and make sure that this picture looks right. Cool thing about Desmos is anytime two functions that you graph intersect, it gives you a dot there. And you could just hover over the dot and check that it is the point 4, and it'll put it as 4, comma, 0.4, which is what we expect. So, okay. All right. We have one more example I want to get to. I'm going to try to do this really quick because we are running out of time. Everybody get that?
Yeah.
Whenever you see, find the equation of a tangent line, this is what you do. You find the derivative of the function. Then, at some point, you write y equals mx plus b, and you do what you've been doing since
Beginning.
since algebra 2, right? And you'll notice that everything I've been saying, like, it's exactly the same. The only question is, how do we find the slope? It used to be like, well, it has to be given somehow. Maybe it's like given as a rate or something, and so you know what the slope is. Here, you're actually using a derivative to find the slope, but everything else is exactly the same. So this is similar to number 85, but I made it up. So find the equation. No, sorry. Find a quadratic function. In other words, f of x equals ax squared plus bx plus c. whose graph has horizontal has a horizontal tangent line at the point 1, comma 2.
Oh, horizontal. So it's just like the root.
We'll
Oh no, the vertex.
talk about this. They would, yes, it would have to be. And slope is 8 at x equals 3. First question. How many unknowns do we have?
3. A, B, and C.
Right. So in other words, this whole question is, we could say, find A, B, and C. So we have 3 unknowns. How many equations do we need? We need 3 equations.
Wait, if you plug in a 3, you get an 8. That's... Oh wait, no, never mind.
Mm-mm.
Oh, slope is 8, yeah.
If you plug in
Yeah.
1. No.
Plug in a 1, you get a 2.
Yeah, because a horizontal tangent line has to be, it has to touch the actual function, right? So we have some function, I don't know what it looks like, maybe it looks like this. And we know that, that there's a, who cares if it's horizontal? If I say there's a tangent line at 1, comma 2, then for it to be a tangent line, it has to be the case that when I plug in a 1, I get out a 2. Otherwise, that line is not on the curve, is it? Right?
Wait, that's not horizontal though.
No, it's not. I said forget horizontal. That's what I was saying. Like I'm just saying, like any curve, you give me any curve in the world and I tell you that there's a tangent line here at say 1, comma 2. Well then the value of the function there must also be 2, right? Otherwise it's not a tangent line. So that's okay, so we need 3 equations. Here's one of them. When I plug in a 1, I got to get out a 2. So f of 1 has to give me 2.
Yeah.
So there's 1. 2 other equations that we need.
Well,
Here's an x equals 3.
so if you
Something
take the
happens to x.
derivative,
If you take the derivative of f, so let's do that real quick. What is the derivative of f?
2a times x
2ax
plus b.
plus B.
plus b. Okay, so what about the derivative?
Now, when you plug in a 0, wait, when that equals 0
When that equals 0, it equals 0 where?
at 1,
At 1.
Yeah.
The horizontal, so the tangent line is horizontal. Let's just think about any kind of function that has a horizontal tangent line. Its slope must be 0 there. And what this is saying is that it has a horizontal tangent line at 1. And so when I plug in a 1 into the slope function, into the derivative, its slope must be 0. There's your second equation.
and then the third one is just the same, but with, so like derivative of f of 3.
Yes,
Equals
this
8.
is telling me that at 3 the slope is 8. And so, in other words, you have some function, and when you plug in a 3, the slope there, the slope of the tangent line is equal to 8. Okay, so there's my 3 equations. I should be able to solve this. Okay, so 2 equals f of 1. What is f of 1?
X
a
squared.
plus b plus c.
Yeah, a1 squared plus b times 1 plus c, right? That's what I'm doing right here, which is just 2 equals a plus b plus c. So there's my one equation. Now, 0 equals f prime of 1. So 0 equals
A plus b plus. No. Sorry.
A, that's
2a plus b.
2a times 1, 2a times 1 plus b, or 2a plus b, okay? Right, because that's all I've done. I've just plugged in 1 into this function. And now my last one is what?
A equals 6a plus b.
Yeah, because plugging that in, f of 3 should be 2 times a times 3 plus b, which is 6a, thank you, yes, 6a plus b.
Can we use a matrix?
You can,
But 3 by
you know, and I don't know whether or not it would be faster. What I'm going to do here is say, how about b equals negative 2a?
Yeah, and then just
And now I could do that, right? I could do that in here and say 8 is equal to 6a
minus 2.
minus 2a. So 8 is equal to 4a. So a is equal to
2. And then
okay, so now we have one of these, and now I could just get it back into here. I take this back into here and get minus 2 times 2.
okay, so b equals negative 4. And you can just plug
So
them
that
both
b
in. Plug the
equals
first and c.
negative 4.
And just plug them in both in that way.
Okay, so 2 equals 2
2
plus minus 4
plus c.
plus c. And so
then
I have
c
2
is
equals minus 2 plus c.
4.
C equals 4. Now I would really appreciate it. Like, yeah, you're done. But I would like to just see the function
Yeah.
as well, right? And so, and this is what I suggest you do with all of these, especially now that you're learning calculus. You guys really want to start investigating this stuff. What we get is 2x squared minus 4x
plus
plus 4. Go plug this into Desmos and check that at 1, 2, it does indeed, when you plug in a 1, it gives you out a 2, right? I mean, you could do all of this by hand, or you could just, and it'd be really good to reinforce this stuff. Just plug it into Desmos. Plug it in and look at what happens at 1, and you'll see, like, yes, this is what this thing looks like. It looks like this. You plug in a 1, you get out a 2. The tangent line there is indeed horizontal, and when you plug in a 3, you get out, I think it's like a 10. But yeah, it's like an 8. You could really go for broke and see, like, can I find the equation of this line right here? Y equals mx plus b. Well, it would have to be, the m would have to be what? What's the slope here at 3?
8.
8x plus b. And then you'd say, well, if I plug in a 3, I get out a, I think it's a 10 or whatever. And then you could do that and find blah, blah, blah. Graph all that and see, like, okay, yes, I'm good. This will really help to reinforce all this stuff that you're doing. Give you more work with finding tangent lines, which is a big, big, big thing that we are going to focus on a lot. Actually finding equations for tangent lines. Believe it or not, it's going to lead us somewhere that we really want to go. And I want to get you guys to get real familiar with, you know, given some setup like this, can you find the equation of a tangent line? It's not just enough to find its slope. Like, I want the equation of that tangent line. That will be, moving forward, that will be, the more familiar you are with that now, the easier the big step we're going to take later this year is going to be. So I want to give you lots of practice with that. That's all I got, guys.